A gait cycle considers the time, events, and movements associated when one foot comes in contact with the ground to when the same foot comes in contact with the ground again. Stance phase occupies 60% of the gait cycle. It begins with the heel strike, then foot flat, and lastly mid-stance. Heel strike phase, also known as initial contact, begins as the heel of the foot touches the ground and is the first phase of double support. As the forward leg travels through space to find the initial contact of the heel with the ground for the next forward step, there is an increased weight on the front foot, but the foot behind still supports the body weight and is still in contact with the ground. The quadriceps femoris contracts in order to extend the knee 0 to 5 degrees of flexion and complete hip flexion at around 30 degrees before the heel strikes the ground. At the ankle, the dorsiflexors, such as the tibialis anterior, fire to lift the ankle up at 0 to 5 degrees so the foot clears the floor and the heel can strike the ground. Next is the foot flat phase. During this phase, the forward foot shifts weight from the heel onto the full surface of the foot as the weight of the entire leg lines up over the foot. The back foot has now left the ground and is in the air moving forward during stance phase of the front leg. The trunk above also shifts forward over the leg as the weight is carried by this front leg. During the foot flat phase, the hip moves slowly into extension caused by a contraction of the adductor magnus and gluteus maximus muscles. The knee flexes to 15 to 20 degrees of flexion. Ankle plantar flexion increases to 10 to 15 degrees. The foot remains in neutral or slight dorsiflexion and the knee stays extended, but the joint is stable so there is less action from the quadriceps. The lateral muscles of the upper leg, such as the abductors, fire to provide lateral support to the leg, and the adductors fire to hold the leg under the body, as the knee begins to flex for swing through. In the stance phase, the hip moves in the direction of extension from neutral in full stance phase. The knee also remains extended during this phase. The ankle moves from dorsiflexion into neutral and then into slight plantar flexion as the foot prepares for the toe-off phase. The trunk shifts from behind the forward leg to over the stance leg. In the mid-stance phase, the hip moves from 10 degrees of flexion to extension by contraction of the gluteus medius muscle. The knee reaches maximum flexion and then begins to extend through the quadriceps muscles. The ankle becomes supinated and dorsiflex at 5 degrees, which is caused by some contraction of the triceps surae muscles. During this phase, the body is supported by one leg as the body advances over the stationary foot. At this moment, the body begins to move from force absorption at impact to force propulsion forward. During mid-stance, the tibialis posterior and flexor hallucis longus display their greatest activity. The mid-stance phase is considered in the diagnosis of many abnormal orthopedic conditions and in the analysis of the associated weaknesses of certain muscles and muscle groups. Heel off begins when the heel leaves the floor and as the hind foot contacts the floor for double support stance. In this phase, the body weight is divided over the metatarsal heads. Here we can see 10 to 13 degrees of hip hyperextension, which then goes into flexion as the sartorius, iliacus, psoas, and pectineus muscles contract. The knee becomes flexed at 0 to 5 degrees through the contraction of the biceps femoris and the ground reaction force. The ankle supinates and plantar flexes at around 0 to 20 degrees through the soleus and plantar flexors, while the swing phase occupies the other 40%, with the toe off, then mid-swing, and lastly the heel strike. The toe off or propulsion phase comes after the heel off, preparing to propel the leg forward for the swing phase. The opposite leg has now moved forward and is taking most of the body weight on the opposite side. The hip joint hyperextends at 10 to 20 degrees by the contraction of the gluteus maximus and hip extensors. The knee joint flexes at 30 degrees through the biceps femoris, semitendinosus, and semimembranosus as the person then uses the ball of the foot to push off the ground and swing the leg forward. The plantar and toe flexors fire strongly to push the foot at 20 degrees and propel the leg forward. There is slight contraction by the hamstrings as the leg begins to move into knee flexion. The quadriceps fires to begin to move the leg into hip flexion. Mid-swing is the period immediately following maximum knee flexion and continues until the tibia is vertical. In the mid-swing phase, the hip flexes to 30 degrees by contraction of the adductors, and the ankle becomes dorsiflex due to a contraction of the tibialis anterior muscle. The knee flexes 60 degrees but then extends approximately 30 degrees due to contraction of the sartorius muscle. This extension is caused by the quadriceps muscle. Terminal swing is the period just before initial contact from which the tibia is in vertical position. Hamstrings fire for a lengthening contraction at the terminal swing phase as it returns the elevated leg into a roll of decelerating the forward motion. This controls the leg as it moves into knee extension in preparation for heel strike. Otherwise, without hamstring control, the leg would snap into knee extension too rapidly. The ankle is held in from neutral position to dorsiflexion due to the tibialis anterior, while the hamstrings fire to flex the hips at 20 degrees. The knee flexes from 0 to 5 degrees due to contraction of the quadriceps to a lock extension of the knee. This combination, along with the forward rotation of the right pelvis and external rotation of the right hip, results in the maximum length of the step.